Well, we're going to talk about TRAPPIST-1d is a small exoplanet, 40% the mass of Earth, which orbits on the inner edge of the habitable zone of TRAPPIST-1, located 40.7 light years away from Earth in the constellation Aquarius. The exoplanet was formed by using the transit method. The first sign of the planet was announced in 2016, but it was not until the following years that more information concerning the probable nature of the planet was obtained. TRAPPIST-1d is the second least massive planet of the system. It receives just 4.3% more sunlight than Earth, placing it on the inner edge of the habitable zone, which is a shame because, I mean, it doesn't have the mass to have that atmosphere, most likely. Um, a 2025 study based on a James Webb Space Telescope observation found that the data was satisfactory, consistent with TRAPPIST-1d having no atmosphere at all. Nevertheless, there is still a marginal possibility the planet has an atmosphere, but determining this with greater confidence would require a different detection technique. It was detected by the transit method, um, so they were able to determine its radius. The planet is about 0.788 Earth radii with a small air margin of about 70 kilometers. Transit time evaluation and complex computer simulation helped accurately determine the mass of the planet, which led to scientists being able to calculate its density, surface gravity, and composition. 1D is a mere 0.388 Earth mass, making it one of the least massive planets yet found. Initial estimates suggested that it has 61.6% the density of Earth, 3.39 grams per centimeter, and just under half the gravity. Compared to Mars, it has nearly three times the planet's mass, but was thought to still be significantly less dense, which would get the presence of a significant atmosphere. Models of the low density of 1D indicated a mainly rocky composition, but with about under 5% of its mass in the form of volatile layer. Volatile layer of TRAPPIST-1d may consist of atmosphere, ocean, or ice layer. However, refined estimates show that the planet is more dense, closer to 79.2% of the Earth's bulk density, 4.35 grams per centimeter. 1D has an equilibrium temperature of 282.1 K or 48.1 Fahrenheit, assuming a barrel of 0. For an Earth-like a barrel of zero point 0.3, the planet's equilibrium temperature is about 258 K, very similar to Earth at 255 K. This is why it's a shame it's so small. Under such an active star, I mean, it just has no chance, but it's really in the perfect area for habitability. I mean, it's insane. It is closely orbiting planet with one orbit taking just 4.05 days, about 97 hours to complete. It orbited at a distance of just 0.02228 AUs from the host star, or about 2.2% the distance between Earth and the Sun. For comparison, Mercury, the solar system innermost planet, takes 88 days to orbit at a distance of about 0.38 AUs. The size of TRAPPIST-1 and the close orbit of TRAPPIST-1d around it means that the star, as seen from the planet, appears 5.5 times as large as the Earth from the Sun from the Earth. While a planet at TRAPPIST-1d distance from the Sun would be a scorched, well, the low luminosity of its star means that the planet gets 1.053 times the sunlight that Earth receives, placing it in the inner part of the conservative habitable zone. Its star is an M-type optical dwarf star named TRAPPIST-1, 0.089 R stars mass, 0.121 R stars radius. Yeah. An atmosphere in the James Webb Telescope determined with greater than 95% confidence that thick and cloud-free atmosphere could be rolled out. So evidence to a clear Venus, early Mars, Titan, and extra Earth. This leaves two main possibilities consistent with the data. Either the planet has no atmosphere similar to Mercury or the Moon, which has or termed the satisfactory fit for by the study's author, or there is a marginal possibility that TRAPPIST-1d has an atmosphere with high altitude clouds or aerosols that block sunlight from passing through muting monocle signatures from detection. In the later scenario, there could be an extremely thin Mars-like CO2 atmosphere, a Venus-like greenhouse scenario with high altitude clouds, or CO2 signature of a modern Earth composition when accounting for Earth's water clouds. This scenario lies at the very edge of the two scenario boundary of statistical significance. As such, it cannot be considered ruled out. However, it is also not a good fit for the data. These scientists, Paulette Garib, what a difficult name, said the detection method they use, transmission spectroscopy, is only one of multiple approaches, and while the study result doesn't kill our specifics for finding some kind of atmosphere, it will be a bit harder after these results. I don't think there's an atmosphere. I mean, B and C are bigger planets, and they probably don't have an atmosphere. I mean, so hey, D almost certainly doesn't have one. That fucker's roasted. I mean, because TRAPPIST-1d is only 50% the Earth mass, like Venus and Mars, may have no magnetic field, which allow the planet stars solar winds to strip away the more volatile components of its atmosphere, including water, leaving its hydrogen poor like those planets. Yeah. It was discovered by astronomer headed by Michael Garland of the two, I mean, some kind of French name, in Belgium. Yeah. That's what we have on this planet. Here's the planets. Here's D. And no, it does not have blue. It doesn't have an atmosphere at all. It's a dead planet. I mean, yeah, here's it. It's cryptid star. Well, that's what we got on this.